Welcome to the GOTO Podcast. In this episode, we ask some well-known and respected names from the software industry what they wish someone would have told them when they were just starting out. Get ready for tips and stories from Mary Poppendieck, Mike Amundsen, Alan Holub, Bernd Rücker, Aino, Corry, and Uncle Bob Martin. Created for developers by developers, GOTO gathers the best minds in the software community. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in Chicago, Amsterdam, and Copenhagen, and by subscribing to the GOTO Conferences YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Hello, everybody. It's good to see all of you today. And today we're going to talk about what did you wish you knew when you had your first coding job? What did you learn later? And maybe a little bit about how you learned it. And because I think stories are a great way to start, I'm going to start out with my own story and pretend that I'm not the moderator for a while. And my first job was in Naperville, Illinois, at Bell Telephone Laboratories in 1967. And in 1967, they had just started coding, bringing up the number 2 ESS, electronic switching system, and they had moved all of the people working on it out to Naperville. And I came from Milwaukee, so I was nearby, and I got a job there, maybe a couple-hour drive from my home. And what they were building was built on, individual components, and it was to replace the electromechanical systems, telephone switching systems in the country. The very first number 1 ESS had been installed in 1965, that is 2 years earlier. And before that, all the switching systems were just plain relays and microwave communication and stuff like that. And the design goal was to be as reliable and approximately the same cost as the electromechanical systems that were already existing. That meant the maximum downtime goal was 2 hours in 40 years. Now, these computers had discrete components. There's nothing to say that they would have anything like 40 years life out of all these individual component computers, but they had a complete dual computer system where all of the lines went into both and they matched each other up. And when one of them didn't match the other, somebody's software went through and threw the bad one out. And there was a 4-hour downtime on the average to bring the computer back up in order to achieve the design goal. So I was to write the software that would go through and check all the individual components on a card and go through all the cards on the bad computer and figure out which was the bad card and print out on a teletype to the repairman, go change this card out, and then it was changed out and they would put the computer back up. So that's what I did for the first year. And what I wish I knew then was, this was quite an amazing thing. And I assumed that everybody knew what they were doing, that all of the people who decided what should happen were smart and were in control, and they knew what was going on and they knew how to make it work. So whatever anybody told me to do was the right thing to do. And I learned some years later that was a really bad assumption. I didn't actually learn that at Bell Labs because they were pretty good. But I was working in 1976. Okay, so it's just about 10 years later. And now I'm at General Motors, and I am programming a mini computer, TI 990, to control an automated vehicle. And because it's a TI 990 that had no high-level language, only assembly language, but hey, I was good at assembly language. And we would take it out on the test track, and we would test drive it. And there was a driver to override it. And every time we went out to test my code, that was the speed control. It's just a plain old cruise control. But cruise control was not a solved problem down at 0 to 30 miles an hour. And so this was a 0 to 30 miles an hour cruise control. And every time we went out on the test track, it would go zoom and then slam on the brakes and zoom and slam on the brakes until the driver cut it out and it just wouldn't work. And I could not get it to work. I checked everything, and I was, as I said, pretty good assembly language programmer by then. And I decided to ask the engineers about the algorithm that they had me program. You know, like, where did this come from? Are you sure it's right? Could it possibly be the algorithm? Well, they, of course, assumed that it had to be software, because who could program in assembly language, all that complicated stuff? And I got very frustrated. So what I did was I decided that maybe the algorithm was wrong. And they didn't have the time of day to look at it. So I went and I bought this book here. Okay. Automatic control. This is a very thick book. And, you know, it was the college textbook for control systems at the time. And I read it, you know, cover to cover. Well, I read it at least 3/4 of the way through until I could, they gave me this article. They said, these people at Ohio State, they're doing the research on this 0 to 30 cruise control. And here's the algorithm. And they showed me this research paper, and that was all they did. So I couldn't read the paper. So I read the book, understood control theory, read the research paper again, then looked at the algorithm. And after a couple, 3 weeks, I got to the point where I could find that there was a mistake in the algorithm they gave me. So I went to the engineers again, finally, and I said, you know, it was the gain. And if you know what gain does, it goes zoom and great, zoom. And it was off by about a factor of 100. So I went to the engineers and I said, so, you know, this constant right here, based on this in the paper, don't you think perhaps it should be this number, which was, you know, 2 orders of magnitude away? And they said, oh, yes, you're right. I put in the new gain and we went out on the test track and it worked. And that's when I learned that, you know, your job is not to do what you're told. Your job is to understand what results you are supposed to get and figure out what it takes to get those results, even if it means studying a college course in control theory. So that's my story.
Good story. I love it.
Okay, so who would like to go? No, anybody got any questions? That's what I'm supposed to ask next. Who'd like to volunteer their story?
Well, mine's a little less entertaining, but I'll go ahead and offer it anyway, just to get it out of the way. So okay. I got into computers rather late. I never studied computers in college. I was bad at math. I was a musician. I was looking for work, and computers had kind of entertained me from a hobby side. And so I kind of pitched myself, this was the microcomputer era. So I said, oh yeah, I can do that. And I worked in a social service organization in Northwestern Ohio. So they needed to keep track of a lot of information about patients and care and budgets and all these other things. So I understood this kind of stuff. And they said, well, we need to buy some computers. And I said, well, I'll help you buy one. I made sure we didn't buy the new hipster computers. I made sure we bought the tried and true business computer that all ran CP/M. So at least somebody appreciates that decision. So I did a little research, you know, so I started building. But here's the thing: I kind of didn't using the language I was using the setup I was using. I understood that programming computers is programming lots of small utilities and stitching them together. I didn't really get this notion that there's this large scale application that you design and build and you review and so on and so forth. I built it piece by piece by piece. And I learned all about pipes and filters and everything else. And it turned out that I built lots of really great utilities that no one else could use. So then I solved that problem by writing a script that everybody could just type one thing in, because back then it was still all command line interface style. So what I learned in that process was your perspective, your starting point is super important. It took me years before I realized, oh, there's interfaces and there's large scale applications. And I really should have learned that a lot better. Now, the good news was when I got involved in the web and APIs and services and distributed systems, all that command line utility stuff was really paying off because I kind of have that built in my head, and I still do today. I still build a lot of little DSL utilities and that kind of thing.
So you never actually learned, right?
No, I never did. I never did, honestly. I'm not to be allowed near any real user experience material because I just never got it. I just never did. So instead, I continue to write these small utilities or these little connectors that solve little job runs, these kinds of things. And I've been able to carve out an enjoyable experience from that. But I definitely made some really bad assumptions early on, and it cost me for quite a while. Now, it turns out I adapt and I learned enough, but I had started from a very unusual standpoint. And that was in the early 80s, like must have been 81, 82 when I started. Yeah. That was it.
Any more comments about that?
Questions?
Any more magicians?
Magicians? You mean musicians?
Yeah, musicians.
Magicians too.
Yeah.
I'm a musician.
You are?
I am. Yeah, I started out. I got into computers because I was interested in computer music. So I wanted to learn how to. I was actually a medieval history major at the time and ended up graduating with degrees in both. But I started taking CS classes because I wanted to program synthesizers.
So
which
you
I don't use
tell us
anymore.
About your first job and what you wish you knew?
My first job, actually, I started out as a hardware engineer. Really? So my very first job was not a software job. In fact, I personally, with my own hands, built the error correction board in the Hubble Space Telescope. It was wire wrap and ECL logic, if anybody remembers that stuff. With ECL logic, you had to deal with faster than light problems in the wire. You take a wire off a pin and you'd wrap it around the board 4 times, and then you'd put it onto the pin next to it so you could get the correct clock delays. Right? Speed of light was an issue. So it was interesting stuff. And the first software job I had also started out as a hardware job, as we were doing robotic systems. And we were using an old Motorola computer with 68,000, if you can remember back that far. And there were no compilers for the 68,000. Motorola's user tech support was just miserable. And unlike Intel, they did not provide compilers. They didn't provide any kind of development environment. It was just nothing. And so the first real software that I had to write was a compiler for the Motorola 68,000. It was a C compiler for the Motorola 68,000. And the second piece of software I had to write was an entire operating system to run this robot. So I sort of jumped in full blast. But it was an interesting.
990, I was programming, no compiler, no nothing either. But I just programmed in assembly language instead of bothering with the compiler.
Well, I did a bunch of that too. I think one of my first experiences with what I thought of as production code, which taught me that production code wasn't what I thought it was there was a problem in one of these robots, and my boss at the time said, look at the code, figure out what's wrong. And I looked at the code, and it was this massive assembly language. And inside the assembly language, there were 3 branches, each of which had a go-to branch to the middle of one of the other branches, right? So you had 3 loops, and then a branch from here to there, based on right in the middle. And then that fell through to the second one, and then it branched down to the third one into a different place. It probably took me a week to figure out 100 lines of assembly language. I had to I don't know, it was hellish. Okay. And and that certainly taught me a lot about how things were not supposed to be done, right? The guy who wrote this was really proud of it. He was saying, it's elegant and it's fast and it's small. And I'm going, none of this matters. Sitting here as the poor guy who had to deal with it, right? I'm saying to myself, none of this matters, right? None of these standard engineering at the time criteria as to what makes good software counted, because it took me 2 days to figure this thing out and to unroll it. And once I unrolled it, it wasn't much bigger much, all of the criteria that this guy was so proud of were still there, but you could read it. And being able to read it was an important thing, I think. So I guess that was the first lesson that I learned, was dealing with all this badly written by engineer code. I guess the other side of that is you should never trust a hardware engineer to write software. Is that we all see that. We see that in Logitech equipment all the time, right? All these hardware engineers writing software.
Yes, indeed. I had a Logitech clicker that I had to throw out because it had a button on there that if I was giving a talk, you push that button, it would bring me back to the beginning of the talk.
Yeah, I know that.
There was no way to defeat it. And everybody who ever had that clicker in the hand eventually, during every single talk, eventually hit it once. And everybody.
There is a way to defeat it. I wrestled with that same problem. Yeah, on the Mac at least you can run Carabiner, and what Carabiner does is it maps anything into anything. So it was capturing that keystroke and turning it into something that was reasonable.
Okay. Okay. Any other comments about his discovery?
I just thought of what he said, a hardware engineer is a bad programmer. And I remember one professor I had at the university, and he was really proud of doing these assembler classes. And that was a time when Java was a thing. So assembler was kind of, okay, you have to learn the basics, but it was not the thing. And he did an exam with a self-modifying assembler program. And that was and he was proud of that exercise. And at one point in time in the class, he told us, like, he thought about it, and he thinks assembler is kind of object oriented because you have the code and the data like close together. It was like, so that was my experience with hardware engineering. So I'm in doubt as well.
So you want to tell us about your first job and what you wish you knew?
Oh, happy to. So I started later than all the stories here. So, but I started kind of I started programming when I was a kid. So I did a lot of like games and a couple of other things. And during high school, that was kind of the first, let's say, professional thing I programmed. A friend of mine, he did kind of a graphic cards business. At that point in time, you could mod or overclock graphic cards to get more, just more out of it if you're into gaming, because this like power was quite expensive. Mining was not yet a thing. It was really for gaming, and you could test that. So he tested these graphic cards to sell them if they can be overclocked like this. And that turned out into a pretty successful business, actually. And he did that with piles of graphic cards in his home and with emails like sending around and stuff. And said like, hey, look, this has to be better. It's like, yeah, sure, this should be better. And then we basically dived into what I would like, looking at it now would be really like analyzing the process, the business processes that are going on. Like, okay, what do you have to do for returned goods? Okay, what do you have to send to the customer? What tests do you have to do in what order, what sequence? And we tried to automate the essential parts to basically remove the pile of stuff there, the customers calling in, sending emails, hey, what's with my graphic cards and all that kind of things. And that turned out into developing, I would say, a lean ECM system at that point in time, like really handling all that things in Java, automating kind of the core processes. What I just learned last year, I think it's still in production. That was 20 years ago. So that surprised me quite a bit. I wouldn't have given that a year. But somehow it worked. And I mean, I learned a lot, so I don't regret anything there. I learned a lot about how to structure such a system. A lot of things I know now from domain-driven design, for example. What's a domain? What's a boundary between the domains? How do I layer that? How do I automate a process that also spans multiple of these boundaries? But it was quite hard at that point in time because like I'm totally in process automation and workflow engines. So at that point in time, the technology was pretty heavy, pretty not developer friendly, very expensive, big vendor driven, and it was really hard to use actually. And that was quite frustrating. And also technology wise, I mean, we were Java, Enterprise Java Beans 2 at that time. That was a technology which didn't really help. I mean, it was more. Yeah, sorry.
Is there
Excuse me while I spit coffee all over the screen.
Is there
was an
anything-
understatement.
Is there anything that if you'd known it when you started, you would have been better off?
I mean, not really, to be honest. I'm pretty happy with what the result was. It was, I think I struggled a lot with the technology at that time. And that's the big thing I see now, is that we really improved with the technology. I mean, it took me a long time to learn a lot of things, like how to structure the domain, how to do the layering, how to automate the process, how everything connects together, because there was not much I could find at that point in time, like knowledge-wise. There were a lot like EJB books or technology books or probably even architecture books, but very abstract, and I couldn't really map that to my problem. Okay. And I think that's much better now. I mean, with all the things written now around all of these topics, and that would have helped me a lot.
Okay. Any other questions for him? So who would like to tell another story, another origin? So first, there you go, Aino.
Yep.
Did I get your name wrong?
Yeah, well, anything works. I know
what is it?
I know, like I know. You know, I know.
Got it.
Yeah. So I didn't program as a child. I wanted to be a mathematician. I just stumbled upon programming at the university, and I completely fell in love with it. I loved how I could control the computer, so that was wonderful. I did a lot of programming during university and PhD, but it was sandbox projects. I weren't like put into a big legacy system. So when I got out in industry, that's what happened. I got put out into a big legacy system. And what I didn't know at the time was that if there's something you don't know something about, you can actually learn it. It's not just because you're stupid. Because what happened was that, of course, I couldn't just understand that legacy system without any help. So there was one of my colleagues who sort of said things to me that made me sit in the toilet and cry every day at work. And that meant that what I did after that was just like Java server pages and stuff like that, because I completely lost the motivation for programming. I did that for some years. And after that, I've only done it like learning new languages just on my own. And what I wish I'd known then was that it's okay not to know everything, and it's okay to ask for help, and it's okay to feel stupid, and other people should be okay with giving help and not laughing and not ridiculing and actually trying to mentor, because most things can be learned. And I think that's an important thing that I've learned over the years. And I didn't understand it theoretically until about 15 years later, unfortunately, where I came back to my university to do research in how you teach computer science. And then I learned a lot about how you learn, how the brain learns, and how you teach in the best way to support different kinds of brains. And then I learned, so that's why I wasn't actually stupid. I just perhaps learned in a different way than this colleague learned. So I wish I'd known that, and I'm trying the best I can to tell people that they're not stupid. They just probably learn in a different way.
I wish you hadn't got stuck with such a
Yeah, well, that's life, huh?
Yeah, I started out life as a mathematician too, because they didn't actually have computers when I was a kid. No. And I got a master's degree in math because the computer science stuff was not actually there yet. And the guys at Bell Labs were being sent to math, to get math degrees in order to learn how to program. So I definitely sympathize with the math part. And there's so much similar, I always thought.
Yeah, it's just
thinking mathematically and thinking about software.
And solving problems, right? Trying to identify the problem and solving it based on experience and good ideas and guessing and a little bit of magic.
Right. And being wrong a few times.
Yeah.
I was wrong a lot. I mean, I was very lucky that I was in an environment where it was a very supportive group of people. Things didn't work the way I told them it was going to work. Things didn't work the way that they had expected. And rather than give me a hard time about it, they said, this isn't quite right. I mean, I was just very lucky to be in a group where they literally said just that. Well, this isn't quite right.
Yeah. That would have been better.
Right. So I was very, very lucky because I had to stumble quite a bit in the beginning. So I learned early on a supportive environment of people who are focused on how to help you succeed rather than claiming that you failed really made a super difference for me. I was very, very, very lucky because not all my friends have.
And it seems to me that teaching at university, many of the people coming out of there, even though they've been programming their whole life, they really believe that they have to come out there and hit the ground running and be superheroes from day one. And I try to tell them, you're not going to make any value in the first time. And that is okay. That's the same for everybody. Take your time.
I rewrote the same software later in my life. I rewrote the same software 3 or 4 times before I got it right. I was a living example of second system theory. I was like, I learned so much in doing this. This is all wrong. Let's do this again.
Start it all over again.
I'm actually shocked that you think you actually got it right. I don't think I ever wrote a piece of software that I got right.
Probably, and there's no such thing as right. Yes.
Very good. Excellent. Very good.
So who would like to? We got a couple more stories to go here.
Oh, I'll go. I'm in competition with you, Mary.
All right.
Let me see if I can show you this. All right. Somebody has to come up with a year earlier than Mary. So this was my first computer, which my mother gave to me when I was 12 years old. That would have been 1964. You can see it's got 3 bits. 3 ones and zeros, right? 3 little flip-flops, and little rods here are AND gates. And you can program this thing by putting little soda straws on these little pegs here. And you've got a nice 3-bit finite state machine. I just inhaled this machine. My father got me. Let's see if I can dig this up here. Oh, yeah, here it is. Let's see if I can get it. My father got me a number of books. One of the books he got me was this one, which I don't know what even the copyright date on this is.
What does it say again?
Boolean Algebra, 1964.
Aha!
Boolean Algebra. And I inhaled that book. Again, this is like at age 12. I didn't get a job until I was 18. And that was at a company near my house, where I got involved with doing a little COBOL, and oh God, that was awful. And I bailed out of that as quickly as I could. And the company bought a Varian 620. This is in the early days of mini computers, when every company in the world was making their own mini computers. Yep. And Varian Radio was making their own, and we bought one of theirs. And what I and 2 of my high school buddies did was to write for them in assembly language a real-time, time-sharing union accounting system that would control a set of terminals that stretched from our northern suburb into the city of Chicago, where the local 705 truckers union would type in all of the union dues and all of the jobs, and we would send reports back to their AS-Star 35 teletypes.
Right, on this little computer.
Yeah, this one. Yeah, no, this is the one it was working on.
Wow.
The Varian 620F was a 16-bit machine. It had 64K of core. Eventually, they made that RAM, but this was back this would have been 1970 probably. This was a labor of about a year of very long weeks and long weekends. And the one thing that I did not know then, that I wished I'd known then, and I do know now, is that it is completely stupid to work 80-hour weeks.
Yeah.
It got you so far. So did you ever get anything working?
Oh, yes, it worked just fine. We got it all to work, and then we all quit.
Good luck with that, then.
All at once, all 3 of us. We walked out the door. Then I had to go, 6 months later, I had to go beg for my job back. Then I had to work for a little while longer. So another thing that I wish I'd known back then that I did not know is don't quit in anger. And don't quit suddenly.
Don't slam the door.
Walk out the door.
Yeah, never slam a door.
You might have to go back.
Yeah.
Because you may have to go back.
Like
I actually had the opposite experience of that, though. I had a boss once, and I was like objecting to something he was ordering us to do because it was just not right. And he said, "I'm the boss, you're the flunky. When I say jump, you jump." And I just jumped right out the door and was quite happy with that, right? As walked down the hall and there was another company there and I went working for them. It was easy.
Wow.
So if we're going to do show and tell,
right?
here you go, Bob. This is a sheet of IBM 360/65 core memory.
Yes.
There is 1K of memory on here. And some poor person went blind making this with like tiny little ferrite cores. You can't see that on the camera, of course. Oh, you've got a bigger sheet.
Look at that.
My core is bigger than your core.
So you have this 64K memory computer. In 1972, I published an article in IEEE Computer Magazine about how to take a mini computer with 32K of memory, core memory, and expand it to 64K of core memory by using a spare toggle bit. And it was an assessment of the mini computers at the time. And this crazy one that you've never heard of because only 10 were built was the one that I figured out how to double the memory by using an added bit.
Very good.
That's very cool.
So most of the programming I did was for machines, not people. Because I did engineering computing. I controlled machines or things like that with mini computers. And the thing is, most of the time I was working in an engineering office, not a IT department. And the engineers, when they were working on something they'd never done before, they kind of automatically tried stuff out a lot and expected to learn gradually and tested their stuff on whatever pieces of equipment they could get their hands on kind of immediately. So to me, this was, of course, the way one does software. And it took a lot of years. You know, my first thing that I put in a manufacturing plant was a big process control system, but it had all these discrete components because, you know, the process control system can die anytime. And so any given piece could be completely taken out and then put back in again without disturbing the whole thing, because that's the way big equipment works. And so I could make a change and I could have it running within 5 minutes, because that's the way you did with big process control systems. It took me forever to discover that in business computing, you build things and you compile things and you don't run them right away. You have to take all of this time to build and compile and test. And it took me very long time to understand what people were talking about when they talked about this process of test and build and all of that sort of stuff. Whereas we built something, we pulled it out, we plugged it in again, and we did it hot, even when it was in a manufacturing plant. And that's the way engineers worked. And when I discovered that, you know, lots of software people work different ways, I was pretty astonished.
Pretty astonished.
Pretty astonished.
Yeah, and that was the same. It was the same for me too, because I had conveniently avoided learning and teaching, training. I just did the same thing. I remember working in a system where I knew we had to fix a bug every single day, and you couldn't drop the system. So we were designing it so that I could change something without breaking anything else, and we knew that we were going to have to swap parts out. So. Yep. Early on, what I didn't realize are these things that now have names like Agile and Lean and all these other things. We were just trying to make sure we solved the customer's problem today. I didn't really pay attention to what I was doing.
Because I was thinking about that the other day, though, right? Because the first shop I worked in would be an Agile shop by today's standards. So Agile was just a glim and high at the time, right?
True for most of us?
It was like everybody was relaxed. We didn't have a boss telling us what to do. We all worked collaboratively. Yeah. It was like Agile, right? It's the way it's supposed to work.
Right,
and it
Mary,
kind of shocked
that's what you
me
were
the first
saying.
time I had an experience with people working in a big corporation where they were not allowed to work that way. I couldn't get it, right? Because it just seemed so ineffective what they were doing.
Yeah. I've had discussions with people in small startups where they said, "No, we're not doing Agile. We hate Agile." And then do you talk together every day? Yes, of course. Do you talk to the customer? Yes, we do. Can you change the software based on what feedback you get? Yes, of course. That would be stupid otherwise. And, okay, you're not agile. Yeah.
Who needs agile, right?
Yeah, right.
Yeah.
It's because agile in some cultures is a bad word, right?
Yeah, and we were even doing it in the hardware. Back in the day, it was all wire wrap, so you could adjust the hardware as needed. So,
Yeah.
And one of the things that I was sort of not really a boss because I was just a kid, but people were paying attention to me when I told them what to do. And I forced one of the hardware engineers to write a device driver for his own hardware. And that made huge changes within the organization. Suddenly they
unit test for your hardware, right?
System,
That's a unit test. Exactly right, Mary.
Yeah.
But
That's great.
I would agree that we all know all these agile paradigms and the advantages, but what I'm still kind of negatively amazed is if I get into big corporations, you very often see processes that are absolutely not agile. And you talk about these, like I use Accelerate the book and all these DevOps reports based on that a lot to make a case for developing more agile. And it's still a thing. It's still something you have to talk about in a lot of organizations. That puzzles me a lot, to be honest.
I was saying that the other day about speed, right? Is everybody talks about speed. Sutherland had a big, was a big, he's to blame for that focus, right? It's faster, doing everything faster. But I go into shops and it's like they say we need to do things faster, and then they categorically and absolutely reject everything they could do that would speed them up. Right?
Not that way.
Right?
Not that way. No, you're wrong.
Yes.
That has to be wrong. Wow.
Somehow, I think people who start out, the very first programmers were scientists and engineers and mathematicians and a few musicians thrown in there, and
Yes.
and the way you think is not, let's gather everything together and do a great big thing. It's let's do one thing at a time and try it out. That's the way you design hardware. That's the way you build pieces of equipment. And, software is just a sort of another add-on. Somehow the aversion to making mistakes grew up since I'm biased and I'm an engineering programmer, I always thought those business programmers, they just didn't know how to do things. Who would ever want to do business programming when you could do engineering program? When you could actually look at a piece of equipment and watch it move and say, I did that. I made that work.
Well, even that, is that on the robotics side, I had to talk to people on the business side who are writing programs that interface with our robots.
Yep.
And I remember once I wrote down a specification. I said, here's what I want here's the way the hardware is going to work. The software doesn't exist yet, but here's the way it's going to work. And the business guys were going, ooh, I've never seen anything like that before. This is really useful. And I'm going, what? So they had never seen a specification before.
Never.
Which makes me wonder what they were doing. It's kind of,
yes,
right?
They were doing what Mike did when he started his first job, right?
I guess so. Yeah.
Right.
Yeah.
Exactly.
Yeah, but they were the real programmers, right? We were just the hardware guys. They were the real programmers, and if they didn't know what they were doing, then nobody knows what they're doing.
But what killed it then? What made software developers stop looking at what they did all the time and inspect and adapt? What made them stop? Was it the large deployment cycles? Was it the
I don't think they have stopped. I've never stopped. I started that way. Companies I work with, they do that, like the small startup. That's the way they work, right?
Everybody in this room is doing it right. But those who stopped, why did they stop?
I don't think they stopped. I don't think they ever started. I think the big corporations that we all wrestle with all the time as consultants started out thinking about factories. And they thought that you design and build software the same way you build stuff in a factory. It's an assembly line. And they just never questioned that. It's not like they did it right and they stopped. It's that those particular companies started that way. They started thinking that way, and they can't break out of that way of thinking. And meanwhile, all the startups are not thinking that way because they didn't have that same experience, right? So it's much easier for them to be agile in the real sense of the word because there's not all these forces getting them to think in an assembly line. It's an assembly line, right? Is that they're just not thinking that way.
Imagine the crazy growth that's been going on amongst programmers. How many programmers are there in the world today? How many were there in 1965? And the difference is many, many orders of magnitude. And so there was this moment in the 1970s when all of the original older programmers kind of started to retire. And in from the universities came a flood of 20-year-old idiots like me, right? And we didn't know how the heck to do any of this stuff. And the business world was there with open arms saying, my God, do we need programmers? Come on in, you can write COBOL, you can do all this work. And all the original programmers who really had worked out this agile thing were gone. They were gone away. They were retiring. And the software world went through this 30-year upheaval of trying to figure out how the devil to get this to work. And it took us 30 years. It took us till about 1995 to actually start getting a clue again.
So they were programming assembly line. They did a little bit and passed it on, and did a little bit and passed it on, and didn't know what it was used for. And
think of the wild growth. You know, every 5 years, there's twice as many programmers as there were before. There's nobody to teach anybody. There's no way to get the knowledge to move through this huge cohort of people. So we're literally every 5 years, we're starting over again. Trying.
And there's nobody to sort of be the coach, manager.
Yep.
And so it turns out these people are working for somebody who has no clue what they're doing. Like, no clue at all. And so all they can do is impose rules and processes because they don't have any clue how to coach these young folks.
Yeah, but it's not the cluelessness that's the problem. It's the being convinced that you do know when you don't.
Well, there you go. Yep.
Right. They are clueless, but they're not open to learning new ways of working. Right. And that's probably the biggest problem with the big corporations I go into is people have this idea that this is the way business works. Of course, you've got, line managers. Of course, you've got roadmaps and upfront plans, and there's no other option. This is the way it works. And they can't imagine alternatives. And you try and explain an alternative, and they look at you like you're crazy.
Except they don't
do
that typically in their core line of business. If they're insurance companies, they do very agile insurance products. If they're banks, they do very agile banking products. If they do manufacturing, they do very rapid changing to manufacturing lines. But this stuff called software, there's nobody in the leadership of the organization that gets it. So they pawn it off to a cost center and say, you guys figure that out and, keep your costs down because, but we need you. But you don't see in their core line of business the same approach.
I did a job for Fireman's Fund, which is just north of here, years ago now, and they really did it right. They didn't know what they were doing. They just did it instinctively. So they had like 7 or 8 teams working on this. They were redoing their insurance adjusting software, and they pulled their 7 best insurance adjusters off the line and assigned them to the teams for a year, so that they could have an on-site expert telling them what to build. And that they just did that instinctively, and it worked out well.
Yeah, because they were messing with their core product.
Yeah.
Right. Yeah. And when an organization messes with its core product, it knows how to build that.
But I'm not sure if I totally agree for especially insurances and banks. I think the understanding that they are basically a tech company nowadays, that changed over the last 5 to 10 years. I think the understanding changed. It's just simply pretty hard to change such a big organization. And at the same time, it's really hard to get good people because everybody needs developers. We just learned we don't have enough, independent of the point in time you're looking at that. And that means you don't have enough people, and you have to change the whole organization, and you have to live in that like digital transformation world, which is kind of scary in a way as well. So I think there's a lot coming together. And even if you have that understanding now, and I think a lot of organizations have. It's simply hard to get to where they want to get to. And I think this transformation takes a while. And of course, that's much easier for a startup, which starts from scratch, with had these enthusiasm, which probably attracts good developers. It needs a handful to do something. And that's hard for a large organization. Just to be fair.
Large organizations that were born before the founders understood anything about computers. But if you look at the big, large tech organizations, they have not had to go through that because they were born right.
Well, born.
Yeah, I'm not sure I agree with that. You know, I look at Facebook and I look at Uber, and I'm not very impressed.
True enough.
By what they're doing, you know, is there's a lot of stuff wrong there, right? A lot of which has to do with the personalities, I think, of the people that founded the companies. And
but I think I could agree with the point that they are born with, let's say, digital native in mind. And that's different to an insurance company like founded 100 years ago, living with a different mindset for quite a long time, having the legacy now. That's, I do see that point. I just wanted to be fair. I mean, I'm not a huge fan of big organizations. I worked at Lufthansa for quite a bit during my university. And after that, I'm not sure if I should say that on recording, but I was done with big corporations. I was like, no, never again. So I learned that at least at that point in time. But I think we also have to be fair with them. It's pretty hard to be a large organization and to adjust the way of working and to make software development part of your heart of the organization. That's a huge change. And of course, that doesn't happen overnight.
Has anyone seen it happen ever?
Seen what happen ever?
A large corporation steeped in the old ways become agile.
No.
I worked at a large corporation, and the software I did there was always agile, but I did not work in the IT department, which was clearly not. I worked in the engineering world, and right from the start, our practices and the way we approach things was always agile, and it was a great big company. But that was the way engineering was done. It wasn't the fact that it was a big company. It was the fact that engineering was a core competency. And we built very fancy, novel, big raw goods processes and instrumented them and did it for a living and had very good engineers that have been doing it for decades. And they had practices that were very agile. And the fact that I happened to do part of that job in code made no difference.
Right.
That was just another piece of engineering. You wrote code because, you had to do less wiring then.
And that was not a transition, right? That you weren't transforming the organization.
No, there was no transition. And in the IT department, I don't even know if they've transitioned now, but they were very much the other way.
One of the things that I have seen is that
transformation.
Well, I have seen that happen in pieces. In other words, you can apply the strangler pattern to a corporation, right? They can spin off this little skunkworks thing, right? And just leave it alone and let it do something. And then they look at it and they go, oh gosh, that's more profitable than anything else we're doing. And gradually everything moves over to these little skunkworks project, and the rotten core in the middle just kind of dies and sloughs off as it rots. And but that's a big company becoming agile by becoming small companies.
Yeah, right. It's a monolith of microservices. And that's what I was about to say, that if I haven't seen a full transformation either, but I've definitely seen, like, you can't take pieces out of a monolith and make a few microservices and they can live, and perhaps the rest of the monolith have to stay, right? It's a bit like the same, where some of the teams are actually able to have that contact with the future users that they can show and tell and inspect and adapt and go back and have that. That's what I think when I think agile. Inspect and adapt, right? And try this and try this. And some have the possibility to do that. But I also see sometimes that for them to actually do that, they have to lie sometimes to the upper layers. So what I do is that I encourage them to lie. I know it's not good, and idealistically I shouldn't. But if that means that they can do great software for a subset of the customers, I think that's better. But I haven't seen a full transformation. I've only seen that, like carving out microservices.
I've seen that too, where you get parts of an organization that will transform themselves and become agile. But over the years, what I've noticed is that it's not stable, that either they will revert back or they will separate and become separate companies.
Yeah.
Yeah. It reminds me of the Kuhn's structure of scientific revolution, where, he says a paradigm shift happens when some young upstarts come and have new ideas, and the old mental model doesn't work anymore, and it becomes more and more fragile. And then you divide into model defenders, and model skeptics. And the only way to get rid of the old model is for the model defenders to die or to retire. Okay. And I think that it's the mental model of software. Those who are the model defenders are not going to go away, but eventually they will retire. How's that? So
Agile by death. Is that what you're saying?
What?
Agile by death.
Yep.
Okay.
That's
but some of the companies,
Revolutions mean that. No tweets about that.
some of the companies I've worked with, the people who were on top were not defending the old ways. They were just completely clueless. They weren't doing anything really.
Yeah.
Right. And the whether they were present or not kind of didn't matter in some ways. So they weren't pushing back much. In this particular company I'm thinking of, there was one group, a bunch of teams got together and formed kind of a Mongo team. And they literally built a wall around themselves. They went and got a bunch of whiteboards and they built a wall around the area that they were working, and they wouldn't let people without being invited. And they wouldn't let managers in. They wouldn't let anybody in. It was like a black box with respect to the rest of the organization. But they were more effective than any other team in the company, so they were left alone. Everybody was afraid. All these clueless guys saying, I don't know what they're doing, but it's working, so let's leave them alone and let them work. And that worked pretty well, at least in terms of getting stuff out the door.
Well, was it permanent?
That's a good question. It was permanent for the 3 or 4 years that I had any contact with the company. I don't know if they're still doing it. It's been a few years now, and I don't know if they're still doing it. But it was permanent for quite a while by our standards of permanence, right? At least 3 or 4 years, right? So,
if they're not going to change, then the organization's going to have to die.
Yep. Or some portion of it, right? That's kind of what we said before. Yep. I remember being told once I was helping in a budgeting process, and I could tell this team was squirreling money away from the corporate head, like they were inventing things, and and I was the one who was helping. I said, "You sure you want to do this?" And what I was told is, in order to be successful in this organization, you have to have a little larceny in you, and that was kind of like Alan's deal, right? Where what they were doing is they were building a little shell, a nice little protective shell, where when something goes wrong, because this budgeting process was another one of these big upfront kind of things. 6 months later, when something unexpected happens, I'll have a little nest egg. I can go ahead and solve this problem. So what happens is people create all sorts of weird adaptive behavior, right? I can't get this part of the organization to move, so I'll hoard things, or I'll rearrange things, or I'll order all the walls to be built, whatever, in order to protect my team, protect my group, to carry water for I think we've probably all seen versions of this kind of organizational behavior as well, right? It's just the idea of how do I survive this kind of thing?
Well, actually, as I recall, as a technology manager in an engineering department, not an engineering department, but a lab, like a product development department, we were expected to do that. That was corporate culture. Squirrel away some money so that you can, if you're a manager and you don't have a back pocket where you can fund little projects, then you're not doing your job. That was corporate culture. That's how 3M invented many of its new products. Sure. So nothing wrong with that. If you're going to have a crazy budgeting process, then you need to know how to game it.
Yep. 3M is a great example of a major blunder to start, right? Their whole history was they thought they were going to be mining one thing, and it turns out they bought a bunch of land and it's mining something else. Yeah, now what do we do? Yeah, it was brilliant, and it affects their whole long-term culture, right? It's really
the long-term culture, at least as long as I was there, was that there was such a thing as a budget, and you probably shouldn't go over it, but that didn't mean it had to be an honest budget.
There you go.
And if you were a smart manager, you got enough money to fund what you needed to do, and you were judged on whether or not you did what you needed to do, not how the heck the money was spent.
That's right. You're judged on results.
And there was not the same concept of slack. Okay. So, I worked for a very good control engineer who told me, who was the manager of our control engineering department. And he said to me once, I always keep my top 2 engineers unassigned to projects. So then when there's an emergency, I have an expert to send in.
There you go.
And he didn't have to account for that. That was the way he was expected to do his job, because if a plant went down because something was wrong with the control system, you had like hours before you started costing the company tons of money. Mm-hmm. So if you were the head of the control engineering department and you didn't have your top 2 engineers sort of ready and waiting to jump on an airplane or help out any junior engineers that needed it, then you weren't doing your job. And it wasn't like, is everybody busy? It was, could you, within the way you manage things, solve the problems that needed to be solved as fast as they needed to be solved? I think we're running sort of towards the end of our time. So I think, unfortunately, we're going to have to wrap up. But does anybody have any sort of final words, comments?
This has been great.
It's been a lot of fun.
Thank you.
Yes.
Thank you. It's been a lot of fun.
Yep.
Thanks, everybody.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech for lots more content from the brightest minds in software development.